Hi everyone, thank you all for coming. Today's topic is all about tracking user activity logs. My name is Paula and I'm from Split, Croatia. I'm a lead backend developer at a small company called Locastic. I'm mostly working with the Symfony and API projects. So the Locastic is an agency with around 30 employees. It's also located in a Split. We are working mostly on challenging custom projects for clients, and we are traveling a lot, visiting and speaking in conferences, and we also love to work on open source projects. So this story started when the client came to us and asked us for a new feature. You guess it is about tracking activity logs. So we asked her to give us a list of the things she would like for us to track. And she just said, I want to track everything. So I want to track the before and after data, who did it, when the change was made, and so on. But also she wanted to have like a really good user experience where she can search and filter through everything and get to the data very fast. So we wrote down a set of goals we need to fill in order to create this feature. So first one is to track each action made on data. That means to track the basic activities, which are create, delete, and edit actions. And also we should have the ability to add some custom action names. So for example, it could be like a reminder was sent or some PDF was downloaded, which is not a classic CRUD action. So those are not the actions that are made on the database, but we still want the option to track them. Next thing is the ability to define which data should be tracked. So there's no point to track just everything from the database or from the entities. We want to just be able to fastly set down the list of fields we would like to see in our activity logs. And also the important part is we need to include the relationship fields. So for example, if we have a product entity and the relation to the collection of product variants, it would make sense to take some fields from the product variant and save those fields to the product log. Next, we need to have a user-friendly logs view. So our end user is not a technical person, so we can't just dump a bunch of database field names and values. We need to make it a bit easier to understand for them. And we need to support the large amount of data. So activity logs tend to grow really fast, and we need to have the support to handle that, and we should not allow for our application to run out of the memory or become slower after we reach that point. And the logging logic should not slow down our application. So basically, we need to run some logic on each request, and we don't want our user to wait for that logic to run, and then that he gets the response, but we should do it somewhere in the background. So here's the list of the things that our activity log should contain. First one is the entity name, so it can be a product, I don't know, user, order, and so on. Action, the default ones are created, edited, and deleted, and of course some custom action names. Date time, when this action happened. Before and after values. So this one is for the edited action. Here we are just saving the fields that were actually changed. So we don't take full object and save it each time. We just find the differences that happened and then save only those fields. And lastly, we save the user who did the change. It could also be an anonymous user, or it could be some kind of a system change that happened, for example, in some cron job. So now that we have all our requirements in place, we can see some existing solutions and check if they fit all of our needs. So first one that comes to mind is a Doctrine extension from and its loggable behavior. So here we have an example on how to implement it. It's really simple and quick. First of all, we add this loggable attribute on the top of our entity that we want to track, and then also this version attribute to all the fields that we want to track, and that's it. And this is the result. We can see that all of our activity logs are saved to a single database table. So that would make it really slow once it grows, because the filtering and pagination, it wouldn't be very fast when we run on a huge number of results in the same database table. Next issue here is that logs are saved using the database field names, which is not really easy to understand for the end user. I mean, it depends on the naming of our fields in the database. And there is no ability to save some custom action. So we are really dependent only on the database changes here. Okay, so to go back to our list of goals, let's see which ones we managed to fill and which ones not. So we can track each change made on data, but not the custom actions. We can also define which fields we want to track, but unfortunately this one doesn't support the relations. So it supports only the database table fields. Logs are not very user-friendly unless you make some kind of a mapper to the fields. It doesn't support a large amount of data and browsing. And the logging didn't really slow down the response time. But we also have some extra feature that is not in our goal, and that is the ability to roll back the data to the previous state. So this one can be pretty useful. And this, in general, this vendor is really great if you have some smaller project and you don't have some more advanced needs as our project had. So to introduce Logcastic, we decided to create our own open source library for handling activity logs. It's made on the top of Symfony. It supports tracking user and system activities and saving them to the Elasticsearch. We decided to choose Elasticsearch because it supports a large amount of data and it has a pretty advanced searching system. It also comes with the API platform integration, so that means we can fully use the Elasticsearch support in the API platform in order to expose our activity logs to the end user. But also it comes with some useful methods for fetching the data from Elasticsearch and which you can use to expose your activity logs to the Twig. Okay, so let's take a look at the flow. So first of all, in the background, we have a Doctrine listener, which is listening to all the changes that happen on our loggable entities. So it's catching create, edit, and delete. Next thing, it sends a message to Symfony Messenger, and then the consumer takes care of the rest. So the consumer basically compares the data, prepares everything, serializes it, and then saves it to the Elasticsearch. And for the reading logs, we basically read them from the Elasticsearch, and then we have two options: to expose it to the API platform endpoint and to show it to the Twig view. So let's take a look at which indexes do we need for our logs. So first one is the current data tracker. So each time some object is created, we save all tracked field values to this index, and then we use it later to compare our data, so we have those before and after values. And it also needs to be changed on each data change. So it basically needs to be up to date with our database at all times. And the second one is the activity log. So this contains the actual logs. So for each loggable entity that we have, we need to have those two indexes in the Elasticsearch. Okay, so now that we've seen some short overview of the bundle, we can jump to the implementation. First step is installation. So we just compose a require logastic, and we have our bundle installed. Second step is to make the entity loggable. So here, I'm not sure if you can see the code, it's a bit small. Here you have a product entity. It has a few fields like code, name, and there's a collection of product variants. And the product variant looks something like this. It has a code, color, size, and price. So in order to make our entity loggable, we just add this loggable attribute on top of the product, and we define the group we want to use. So in this case, it's a product log. And the next step is to define the fields we want to track. So we add that serialization group we use on the top to the fields we are tracking. And for the relations, if you want to track the product variant collection, we just add the group to the product variant and all the fields inside the product variant that we are tracking. So this is basically the same approach as the API platform has on the resources. So they also define the resource and the serialization groups, which for the fields which will be returned in a response. So this works basically the same, except it is saved to Elasticsearch instead of returned to a response. Next step is to run commands for creating Elastic indexes. First one is ping console, Logastic activity logs, create loggable indexes. And this is the output. So it will take all the loggable entities and it will create those two indexes in the Elasticsearch, but it will just skip those that already exist. And additionally, maybe you already have some data in a database. It's not a fresh project. So you will need to populate those current data trackers so that you immediately have everything you need for creating activity logs. So this is the command, populate current data trackers. It will ask you when you run it, for which entity do you want to populate? You can choose one or you can just choose everything. And that's it. So now our activity logs are tracked. It will automatically catch, create, edit, and delete changes made on all loggable entities. So let's see some examples. Here we have a code for creating a product. We can see that we created a new product. It's a t-shirt and with two product variants. So first one is a t-shirt red small and the second one is a t-shirt red medium, and they both have different prices. So once we hit the save to the repository, our listener is triggered and it created product current data tracker in our Elastic Index. So here in the data field, we can see all the values from the fields that we previously set our groups to. So now we have all the data saved. And secondly, it creates the activity log. We can see that it has the action which is created. It has a date time when it was logged. We also have object ID and object class, which will be used later for filtering and searching. This time, data changes are empty. It's because it's a brand new product, so there's nothing to compare with. And we also have request URL and the user who did this change. And for editing, here in this code, we find this product from the database. We change its name, and we also change one field from a product variant, and we change its price. So the activity log looks something like this. So now the action is edited, but now we do have data changes. So we will always have a previous and the current values in a response. So data changes will be saved in a JSON. And here we can see that we have our name that was changed from the t-shirt to t-shirt edit. And we can see that the product variant with ID 15 had its price 1,000 and now it is 1,500. And of course we have the request URL and the user, which is always here. And also, it needs to update the current data tracker, so now we have the brand new values for comparing for the later changes. And delete product, basically we just remove it from the database and we get this log. So action is deleted and the rest of the fields are the same. We also don't have any data changes because nothing is actually changed in the data. We only removed it from the database. Step 4 is to display the activity logs to the end user. First example is to display it in the API platform. So this bundle totally supports the Elasticsearch integration in the API platform, and you are able to use all of its features on your activity logs. So let's see some code. Here you can see we extended the base activity log class, so we just get all the fields that are by default there. But of course, you can create your own class with your own fields, depending on your needs. And we defined an API resource on top with the operations. So we have get single and get collection. We also had a filter for ordering because we want to show our most recent logs on the top. And the important part is to add this state options configuration and to define the index we are pulling the data from. So here you can see we used a star and activity log. So that means that this endpoint will pull all the activity logs regardless of which entity is. But if you want to use a specific index, for example, product, you can just put product activity log here. Or you can just create a filter for the class. And this is the result. We have 2 new endpoints. The response would look something like this. So first, we can see the delete action because we set the order to go from the fresh one to the newest one. So we have all the fields exposed, but maybe you don't need to expose, like, for example, object class or request URL to the end user. So that's why you can create some DTO to expose only the fields you need. Next one is the edit log. And here we can see in the JSON that we have previous and the current values all formatted. So these fields inside the previous and current values will be the same as the fields in the actual product that you expose to the end user using the API platform endpoint. So the front-end developer can know exactly which fields he can expect for a single class. And lastly, we have a delete activity log. Oh, sorry, create. Second example is to display activity logs in Twig. For that, we have this activity log provider interface, which comes with some useful methods for fetching the data from the Elasticsearch and returning an array of activity log objects, which you can just forward to some Twig view and then create your own design for displaying logs. So first one is get activity logs by class. Second, get activity logs by class and ID. So for example, if you have a single page where you show a single product, you can use that one in order to just show the activity logs for that product. And lastly, we can get them by index and the ID. So this is just some simple example of the controller. It just injects this activity log provider service. It forwards product class and the ID we get from the URL, and then forwards this object to the Twig view. So here is the injected class and the fetching of the activity logs, which are returned to the Twig view. I don't have an example of the HTML that is shown in the Twig because that's something that's mostly different on each project regarding the design of that project. So now we can have a quick overview of the basic implementation summary. First step was to add loggable attribute to the entity and the serialization groups to the properties we want to log. Then we run the command for creating indexes, and finally we expose the API endpoint or display logs in Twig. So while this is a really quick and a simple implementation, we usually need something more. We need to usually customize it to our project needs. So let's see what we can do here. This is the configuration reference. First, we have loggable paths. So these are the default ones where the bundle will read your configuration files. It can be attributes, XML, or YAML files. But you can also add your own paths according to your project architecture. Next, we have a default Doctrine subscriber, which is default true. So it will by default be activated and listen to all those changes, but maybe you want to trigger your logs in some different way, have your own listener, so you can turn this off and create your own. And here we have some Elasticsearch configuration. So we have a host for connecting to Elastic and some date-time configuration. Next, we have the index mapping for Elasticsearch. So we need that for those two indexes. First, activity logs. So here we have all the fields and their types. And the current data tracker fields. So if you want to add some new field or remove some from these two indexes, this is the place where you need to add it. So let's see how we can customize the log to data. Let's take a look at the created log. And here we can see we have a user with a field which is a full name. But maybe we want to have some different data there. So in order to do that, we have a user entity, which is a basic user used for the login. And we just need to add the serialization group activity log, and those fields will be shown as a user in our log. And also don't forget to add it to the Elastic Index mapping. And now we have something like this. Now we have ID, email, and the full name for the user in our logs. Collection keys. So here we can see that the product variant with ID 15 changed its price. But it's kind of hard to figure out which exactly product variant is that. We need to go and find a product variant with ID 15 and then to know which one was changed. So maybe some different info would be more useful here. In order to do that, we can decorate our log identifier extractor, which is used for creating this info. So by default, it will always pull the ID from the object. But if you, for example, have a code in your entity, which Cilius objects mostly do, you can just say, okay, if the object is instance of code-aware interface, then just return the code. The code is usually something like a slug, and it's much more readable, and it has like a better info on what the object is. And if not, you can just call the base decorated method. And now you will have something like this. So now you can see that t-shirt with the color S and the size small changed its price. So let's go back to our product and product variant. We can see we have a product variant collection inside of the product here. And if we have a code like this, so if we only change the product variant field price and we save the product object to the database, then activity log won't be saved. Why is that? Well, because Doctrine listener can't really figure out that you wanted to save the product instead of the product variant, and the listener will be triggered only for the product variant here, because no change basically happened on the product. And the solution for this is to implement loggable child interface to the product variant. And now we have this log2 method, and here we return this product. So this way we will tell the bundle, each time a change happens on a product variant, save it to the product object. And here we have the same code, we only change the product variant price, and here we have our log, so it is saved. Changing the default loggable listener, so we already seen this configuration. We just turn off the default one and create our own. So this is the example of the API platform listener for the post write. So it will be triggered after the data is saved to the database. But if you are using the newer version of the API platform, you can also use the state processor to do this, because the listeners are not really recommended anymore. Here we have the built-in activity log service, activity logger service, sorry. So we have three methods. We can log created item, log deleted item, and log updated item. So this is something we can use to manually trigger saving logs. So this is just a simple example where we switch the request method. So if it is a post, we log created item, for the put updated item, and delete deleted item. Of course, so this is just an example. For example, if you're using Cilius, maybe you can use their resource events in order to save those, or you can just don't have any listener and just decide to trigger logs saving across your code logic where you think it's the best. So custom action name. So imagine you have an order and then you have a bunch of changes on that order. So if you have a list of the logs, it would look like created, edited, 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 and it doesn't say much until you open and see what actually happened there. So it would be better to have some custom action name which is more descriptive. So for example, if we change our shipment and we set the status to the status shipped, then we can log updated item and add a second argument with a custom name order shipped. And now when you have a list of activity logs, you immediately know what happened there without the need to looking more into the old list of the fields we have in activity log. So by default, when we have some edit action, we will only save the log if we have actually some changes happened in the logged fields. But sometimes we still want to save it to the logs. So that can be, for example, that someone downloaded a PDF. So there's no change happened, but we want to save it. So we do it like this. We have a third argument in log edited item, and we set it to true. So this time it will be saved no matter what. And this flag is by default false. Okay, so now that we have our logs, we will usually need to optimize it a little bit to handle a larger amount of data. So first step is to make a log asynchronous. We just define our transport and send all of our activity log messages to that transport. But an important note here is that we can have only one consumer in the setup like this. That is because if we have two consumers, they could change the same data at the same time, and then we would probably get corrupted data. So if we need more of them, we need to have a bit of a different setup. So here is an example where we have two transports and two consumers. First one is activity logs default, where we will send everything by default. And the second one is activity log product, where we want to send only the product activity logs. And at the bottom, we still, by default, send everything to the default one. But how do we manage that the product entity sends to the second transport? We do that by decorating the activity log message dispatcher. So this will by default just take the default transport and send it to that. But we can have our own logic. So we can say, okay, if the class name is a product, then set it to the activity log product transport. So this is a very simple example, but you can have a bunch of transport and more logic for having more consumers, depending how much do you want to optimize. And if not, you can just call the decorated method. So let's see our pros and cons. First of all, it's a very quick and easy implementation. Second, it's flexible and customizable, so it managed to fit all of our needs for something more than the regular CRUD actions. It also met all of our goals from the beginning, if you remember. And this one wasn't goal, but it's really helpful in debugging because clients tend to call us and say that we have a bug, but actually it was just being used the wrong way and the issue was on their side. So now that we have a list of all activities that happened, then they can easily see when something happened. On the other side, it's a bit of a complex setup because you need to know at least the basics for the Elasticsearch and also for the messenger. So that can be a con. And keeping data up to date. So we always need to make sure to keep our current data tracker up to date, or that our logs won't be really correct. So let's see how does it work on real projects. So we are currently using it on 2 of our projects. We will see the metrics for the one with Cilius and API platform. So currently we have 1.5 million activity logs saved in the Elasticsearch, which is really not that much. We expect much more, but we just came to this point until now. We also have the API endpoint for fetching activity logs with the filters and everything, and it's still less than 200 milliseconds the response time. And for the future plans, we would want to add a support for other data storage, for example, for Postgres. I think we need to have a support for some more simple setup so that everyone doesn't have to install the Elasticsearch and get known with it. We also want to add more abilities for customization. We do have some, but we have some more ideas on how to improve it even more. Next one is a Cilius plugin. So since we are already using it on a Cilius project, we already have some views for displaying activity logs, which are made of the Cilius admin components. So sometimes in future, we plan to open source it. And of course, we will keep testing it and fix any issues that we find. And finally, for the contribution, I hope you like this bundle and you will find it useful. So if you decide to try it, you feel free to add an issue if you find one, or even if you have some idea how to make it better, you can open a pull request and become a part of this. And that's it. Thank you very much.